A very good morning to all the students. I am Dr. Hima Bindu from the Department of Mechanical Engineering from Institute of Aeronautical Engineering, and I'll be dealing the subject robotics, and today's topic is definition and terminology in robotic applications which come under the module 4. Firstly, before we step into the definition terminology, we need to know what are the various applications of robot. Generally, the robot applications are being used in industries, in mechanical automobile industries like painting, welding, spray painting, or in agriculture fields, in military areas, right, in hospitals. In all these sectors, we use the robot. So, how this particular robot application has been implemented and how we are using on the short definition and terminology we will be discussing in today's session. Right. So, firstly, what do we mean by spot welding? Spot welding is one of the application in which robot plays a very important role, right? Where the work constraint becomes easier and the time constraint is being reduced, due to which the cost to produce n number of products will be reduced. So when we are defining about the spot welding in robot, generally it is this particular type of the robot carries a gun, welding gun, which consists of an electrode, the cable which are required to conduct the high current, and sometimes a water cooling system for the electrode. Spot welding is generally being done. For example, here we have two welds, right? Here we are having two welds, and we need to weld this particular two workpieces, workpiece A and workpiece B. So this particular type of the spot welding is not being done in a continuous process, whereas at some particular point, at some particular joint, the welding is being done. That is, at some particular spot, at some particular joint, this particular type of the welding is done. That is known as the spot welding robot, where the robot will carry a welding gun which consists of an electrode and a cable with a high current, and wherever the welding is required, the spot weld is being done with the help where the water cooling system is used for cooling the electrode. Next, what are the characteristics of spray painting robots? Spray painting is generally used. Why are we using a robot near the spray painting? This is one of the more important question, because here the paintings whatever we are using to paint the aircraft engines or to paint the automobile vehicles, the paint whatever we are using is very detox, right? It consists of high levels of chemicals, due to which the health of the labor or the help of the worker who is working in that particular spray painting industry will be affected. Now, instead of affecting the health of the workers, when we are replacing the worker with the help of the robot, the work is also becoming fast, and we are saving the life of n number of people who are working in that particular industry. And not only that, the area whatever we have for spray painting is very small. So considering these particular constraint also, we are using a robot in a spray painting application. So this particular spray painting robots has the following characters. That is, it is high level of manipulated dexterity, and it is used for a large working volume, for small base manipulator, and a compact wrist. The small payload, low accuracy, and repeatability. That is, when the work has to be repeated, when we are using a robot for this particular repeated work, the work becomes more easier, the time consumption is reduced, and the cost is also being reduced. That is the reason why we are using robots in the spray painting application. Next, define interlock. Interlock is nothing but it is used to prevent the work cycle sequence from continuous unless a certain or set of conditions are being satisfied. Clear? The interlock is nothing but it provides the means of preventing the work cycle sequence from continuing unless a certain or set of conditions are being satisfied. Next, define intermittent transfer. What do we mean by intermittent transfer? That is, part are moved in a start and stop motion from one station to the another along the particular line. It is from start to the stop from one station to the another along a particular line is known as the intermittent transfer. That is, it is also called as the synchronous transfer since all the paths are moved simultaneously to the next stop. We can also tell this particular intermittent transfer as a belt transfer. That is when we are picking and placing the objects on the belt conveyor. It is a continuous process from the start to the stop motion along a fixed line, along the fixed path. That is known as an intermittent transfer, where the best example we can call it as a belt conveyor. Now, this particular type of the transfer is also called as synchronous transfer, where all the paths are being moved to the next stop simultaneously. The advantage of this system is that the paths are registered in the fixed location and orientation with respect to the robot duration. There will be no movement of the robot in the irreplacement places. It is as we are passing it on a belt conveyor, as we are placing the objects on the belt conveyor from start to the stop, it is traveling with a continuous motion to the stop point simultaneously at a fixed line. That is known as the intermittent transfer. Next, classify work part transport system used in the inline robot work cell. So here we have three types of inline robot work cell. One is the intermittent transfer, continuous transfer, or non-synchronous transfer. We have already discussed about the intermittent transfer. Now, what do we mean by a continuous transfer? Continuous transfer means what? Where the objects are being moved from one place to the other at a continuous motion. That is, work parts are being moved continuously along a fixed line at a constant speed. Right, and the robots has to perform the task as the parts are being moved along. That is, there should be a continuous work on the robot also from picking and placing the objects on the conveyor. And this particular conveyor is been moving the objects from one place to the other in a continuous direction, where the position and orientation of the parts with respect to any fixed location along the line are continuously changing. That is, there is no fixed location with respect to any fixed location. The position orientation of the parts are also not damaging. Whereas it is a continuous, when the continuous process is being taking place, it is known as a continuous transfer. Right? Next, list work cell control. What do we mean by list work cell control? That is sequence control operation interference safety monitoring. Right? When we have a control on a sequence operation interface with a safety monitoring, that is known as a cell control. Define input interlocks. Input interlocks means what? It is something which sends the signal to the components in the cell to the controller. Right? It is something which is sending the signals to the components in the controller. That is known as the input interlock. That is, input interlocks make use of signals sent from the components in the cell to the controller. Next, define part identification problem. What do we mean by part identification problem? Part identification problem means what? It is nothing but one type of the parts. There will be a necessity to identify various parts by autonomous means such as optimal technique. Right? we need to identify the parts, identification of the problem, part identification problem. That can be done only with the help of the optical technique. That is, in the robot, if any of the part has a problem, or if any of the part is facing like for example, near joint one there is some rust being generated and it is not having a easy movement, so that particular part identification problem will be done with the help of the optical techniques. And the magnetic we also have the other type of techniques like magnetic techniques or limit switch that senses different size or the geometry. That is known as the part identification problem. Next, how do you protect robots from its environment? How are we protecting the robots from the environment? That is, in this is one of the type of the application where spray painting, hot metal working condition comes into action. That is the abrasive application. It is one of the abrasive type of the application where adhesive sealing application will be used for the robot to be protected from possible adverse environment. That is, when the robot is being exposed to rain, or when the robot is being exposed to high temperature, what happens? It gets short circuited or it get robust. So we need to take care of the robot in the various different condition, environmental condition. So that will be done with the help of spray painting, hot metal working condition. We need to take care. That will be done with the abrasive application or adhesive sealing application. For example, near the sleeves of the robot or near the end effector or the gripper of the robot, we will be using the protectors to protect the robot from the environment. Next, define mobile work cell. What do we mean by mobile work cell? This is an arrangement in which the robot is being providing with a mean of transport such as mobile base within the work cell to provide various tasks at different locations. That is the arrangement which is used to make the arrangements at various different locations with the help of the mobile base is known as the mobile work cell. Right. What is non-synchronous transfer system? Non-synchronous transfer system means this is a power and a free system where each work part moves independently of other part in a stop and a go manner. That is known as the non-synchronous transfer system. That is a system which is acting on a stop and a go manner, which is independent of the other parts and which provides power and free system, is known as the non-synchronous transfer system. Okay. Next, define repetitive work cell. What do we mean by repetitive work cell? Repetitive work cell means when the same sequence of work is to be done in any of the large scale industry, the robot will be given a program so that it continuously generates the products 24/7. That is a repetitive work cell. That is, in the sequence of elements in the work cycle, when the sequence of elements in the work cycle is the same, the element consists of relatively simple motion. Robots usually perform the work with greater consistency and repeatability than human. If the same work is to be done by the human, some or the other way, there will be some time lag, due to which the cost has been increasing and the production time is also increasing, and there may be some small defects being erased when a worker or a laborer is been working on repetitive work. But the same work, when it is being given to a robot, since it is the repetitive work, it completes faster, the time consumption will be reduced, due to which the production cost has been reduced, and the quality of the product is also good. So the repetitive work cell, generally we use the robots. Next, what is multi-shift operation? Multi-shift operation means when the robot has to shift from one sequence of order to the other sequence, or from second to the third. The robot play a very best example for a multi-shift operation. That is, a robot can replace 2 or 3 workers at a time. That is, the work to be done by 3 laborers is being done by a single robot in a multitasking system that is known as multi-shift operation at a faster financial payment, right, at a faster time consumption, that is known as a multi-shift operation. Define infrequent changeover. Infrequent changeover means what? When the sequence of order is not being changing frequently, that is known as the infrequent changeover. That is, the robot use is justified for long production runs where there are infrequent changeovers as the opposed to batch or the job shop production where changeovers are more frequent, that is known as the infrequent changeover. These are the differences. So in today's class we have seen the definition and terminology of robot applications, which comes under the module 5, in which we have studied about the terms like spot. What do we mean by spot welding? What are the characteristics of spray painting robots, and how is it useful by using a robot in place of the worker? And what do we mean by interlock system? And what do we mean by intermediate transfer? And what are the three types of transport systems being taking place in any of the industry? And what do we mean by continuous transfer system and intermediate transfer system? What do we mean by list work, cell control? And what is the input interlock? We have seen about the part identification, how we identify the problems in various parts of the robot. That will be done with the help of the optical technique that we have defined. Now, and next, how do we protect the robots from various type of the environments? That is the abrasive type of the application, and that also we have studied. Right? And what do we mean by mobile work cell, and what is non-synchronous transfer system? And we have been studied about the repetitive work cell and about the multi-shift operation and define infrequent changeover. Right? Hope you have understood about all these particular definitions and terminologies from module 5. In the next session, we will be discussing the question bank of all the 5 modules in each constraint. Right? Hope you have understood today's session. Signing off for today, Dr. G. Hima Bindu. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.